All right, welcome back, everybody. Let's move on to hypothesis test for a population mean. So just to recap, it's pretty much going to be the exact same procedure here. Now, we know that we're going to be dealing with a population mean. So therefore, we're going to be saying that mu is equal to the true population mean. The hypothesis will now involve mu. It's going to be equal to some value. And the alternative, again, is up to us. So what do we believe is true about this parameter? So we have a one-tailed test, same as before, which occurs when you have an inequality. So either mu is less than the given value or greater than, or you can get a two-tailed test. So let's focus on the stuff that does change. So the steps are going to be the same, except now the conditions will change because now we're talking about a mean. So we're still going to require a simple random sample and independence from individual to individual. Now the shape. So remember that for the shape condition to be met, we either need a big enough sample size, so n greater than or equal to 30, or we need to know that the random variable x is normal. So this is what we did in the previous section when we were given data, and sometimes we need to check normality by checking QQ-plot and box plot. That's about it. The next thing will be very similar. You will go ahead and sketch a t-distribution because it's a mean. And therefore, the command will be stats t-stats. And that's about it. So let's go ahead and take a look at our first example. So according to the American Time Use Survey, the typical American spends 154.8 minutes or 2.58 hours per day watching television. Again, they start out strong with a claim. So please get used to identifying the claim. And then they continue by asking a question about a different group. So internet users. So they're asking, do internet users spend less time each day watching television? A survey of 50. So again, they're giving you the sample. So this is your sample info. So you can kind of ignore it right now. We don't need it right now. That's just the sample. And the problem ends by stating for us to conduct an appropriate test to determine if the internet users spend a different amount of time watching television. All right, so let's go ahead and set this up. So I hope it's clear here that the parameter is mu, which is the mean amount of time for the group that you're interested in. Here it's all internet users. Spend watching TV. All right, so there's my parameter. Now my hypothesis. So mu oh, and they said different, so it's going to be a two-tailed test. All right, so now what could we potentially say is the mean time that internet users spend watching TV? Now, we don't know. So there is this general statement that was made that's highlighted and that says that typical American. So that, remember, the null hypothesis is also the no change hypothesis. We don't really have a reason to believe that the time spent watching TV changes from, subsection to subsection of the population. So we're just going to go ahead and say that this is also 154.8 minutes. Notice that the decimal does not move like in proportions. And that's because proportions, there's a percentage next to it. So if there's no percentage, you don't move anything. All right, so there's my hypothesis. So once we get the hypothesis, we then need to check the requirements. So we're going to assume that there's a simple random sample and independence. The only thing we got to check is, do you have a big enough sample size? So go ahead and read this, a survey of 50 internet users. So N in this case is 50. That's definitely greater than 30. So our condition for the sampling distribution is met. So we got the hypothesis, we have check. Now, notice that even though my sample size is greater than 30, it doesn't mean that before we would say that this would be normal for in chapter 8. We always said if n is greater than or equal to 30, we have a normal distribution. Really, it would be a standard normal. But remember that to make z, you take x minus mu over sigma. And you don't know the mean. In this case, I mean, I guess we could say it's 154, but the real issue is that we don't know sigma. So because of that, we have to replace that with S. And remember that when you replace that with S, you get T distribution. So really the distribution we're dealing with here is T. So let's see, where are we at? We've got the parameter. We've got the hypothesis. We've checked our conditions. So now we just need to go ahead and sketch and get the test statistics. So this hypothesis test we've already done in our intro. So let's just kind of run through this a little bit quick. So let's sketch my distribution. The T distribution, degrees of freedom is 49. So remember that as the degrees of freedom increases, the T distribution becomes more and more normal-like. I see a not equal to, so that's a two-tailed test. Shade in both tails. And let's go ahead and remember that this is alpha over 2. So let's see, what is alpha? Alpha in this case is 0.05. All right, and so that takes care of that. Label your number line here, that's 0. This is an unknown value, but I could easily find that. This is T sub alpha over 2. The left-hand side is minus T sub alpha over 2. Remember that now that we've got the sketch, we can simply use StatCrunch. So it's stats, calc, and T. Make sure that it matches. All right, get 2.0096. All right, so remember the logic. We're basically saying if the mean is not actually 154.8, then I expect to get samples that land in the tails. And that's significant because there's a very small fraction of samples that actually should land in the tails, right? It should be alpha, so 0.05 or 5% of the samples if you do this long enough. All right, so now we can go ahead and get our test statistics. So what is the T-stat? Because it's a T distribution, and then what's the p-value? So we just go ahead and find these using StatCrunch. So let's just maybe highlight our sample information. So 50 internet users were selected, so that's my sample size. The mean time that they spent watching TV was 128.7 with a standard deviation of 46.5. So this is the information that we need. So we're going to do stats, T-stats, one sample. In this case, you don't have data, you have a summary. And then let's just go ahead and record the relevant information. So like the mean, oh, look, it was 128. I guess we've done this before. Standard deviation, 46.5, and sample size of 50. Make sure that your hypothesis test matches your paper. So remember, it was equal to 154.8. And we're testing for not equal to. All right. And so here we go. We have our one sample T summary statistics. We don't really need any of these because we're not doing this by hand. So really, we don't have to look at these. The only thing we need to look at is the T statistic and the P value. So let's go ahead and record those. All right, so the T statistic is negative 3.968 and the P value 0.002. So remember, always try and visualize the T statistic on your number line. So negative 3. Remember, this number is 2.0. This number is 0. And this number is negative 2 point something. So negative 3.9 is very, very way off to the left. It's like deep in that tail. So that's clearly significant, right? We land in the critical region. So we're going to go ahead and reject the null hypothesis. The p-value 0.002 is also less than 0.05. So it is that you can tell the result right away without having to do the sketch if you simply look at the p-value. So the probability of getting a sample like what you got is 0.002. That's unusual, according to the 5% significance level. So now that we reject H0, let's go ahead and write in our conclusion. We're going to say we have sufficient evidence. I hope we also have funds. We have sufficient evidence at the 0.05 level of significance that and then just basically describe the parameter. So that was the true mean time that internet users spend watching TV per day. Does that make sense? True mean internet time. True mean time internet users spent watching TV per day is, and then remember, always talk about the alternative. So we were trying to say that it's different. Is different from 154.8 minutes per day. And that's it. To get more information on this, you would create a confidence interval. So go ahead and create a confidence interval. I'll leave it to you to figure out the confidence level. And you should be able to get a confidence interval that does not contain 154.8. So alpha was 5%, so that means what's left over is 95. All right, so 115.48. To 141.92. So this is our confidence interval. And remember, this means that we are 95% confident that the true mean time that internet users are watching TV per day is between 115 and 141 minutes per day. So what do I want to point out is that 154.8 is not in here. And so because it's not contained in an interval, it means that mu, according to our interval, is not, one of the potential values for mu is not 154.8. could only be values between 115 and 141. So notice how significant that is. The confidence interval actually gives you more information because it tells you it's probably lower than 154, but the hypothesis test, really all we cared about is, do you reject or fail to reject the null? So the hypothesis test always is used to test the claim. Confidence interval is a bit more informative. All right, so that was our second hypothesis test for the mean. Hopefully you now have a hang of how all of this works. We have one more example coming up, but that'll be on the next video. All right, thank you for joining me. I'll see you in the next one.